Good morning grade 6. Welcome back to grade 6 mathematics class. Hope you all are doing great today. So in the previous class, we saw a couple of examples on problem solving. So there we used the strategy of looking for a pattern, and based on that pattern, we drew tables, and that's how we solved those problems. So today we are going to work with a different strategy. So here we have the first question. Let's discuss this one now. This is example 3 in your textbook, which is given in page number 250. It says, in a tennis tournament, each participant plays one match against each of the other players. If there are 10 players, how many matches will be played? So as in the case of any problem solving, the first step is to read and clearly understand what is given to you and what is being asked to find out. So here it says there is this tennis tournament, and how many players are there? There are 10 players. Each player will play a game against the other players, against all the other players. So if that is the case, we need to find out how many total matches are played in this tournament. So how can we find this out? What strategy can we apply here? Can we look for a pattern? No, that doesn't work here. So here, let's first solve a simpler situation, and based on the result of that, let's find out if we can find a pattern and solve the situation given. So here it says 10 players. So let's solve a simpler situation where the number of players is the least, and let's find the possible combinations and try to find out the solution to the situation. So here I have a table. The first row says the number of players. The second row shows the name of the players or the name of the teams. Then the third row shows the possible combinations of matches. Then the last row shows the total number of matches played by them. So when the number of players is 2, let the players be A and B. The possible combinations of matches will be between A and B only. There will only be one match possible with 2 players. Now, what if when there are 3 players? Say for example A, B and C. Which are the possible combinations? See, A and B can play a match together, B and C can play a match together, then A and C can play a match together. So the total possible combinations is 3 when the total number of players is equal to 3. Now, when the players are 4, when there are 4 players, say for example A, B, C and D, how many possible combinations of matches are possible? There are 6 combinations possible. Likewise, when there are 5 players in the tournament, the total possible number of combinations of matches, that would be equal to 10 matches. Now, based on this observation, let's draw a simpler table now. The same case tabulated in a simpler table. So here we have the number of players and the number of matches possible. 2 players, only 1 match possible. 3 players, 3 matches possible. 4 players, 6 possible combinations possible. 5 players, 10 possible combinations of matches. So these are the observations we got when we imagined the number of players is equal to 5. Now, here try to find a pattern here. Try to find a relationship between the number of players and the number of matches, so that we can complete this table and find out how many number of matches are possible when the number of players is equal to 10, as asked in the question. Now let's have a closer look at this table. See here, number of players is equal to 2, number of matches possible equal to 1. The next case, when the number of players is equal to 3, the number of matches possible is 3. Can you find a way in which we can get this number 3 from the previous number of players and the number of matches? See, this 3 is the sum of the number of players and the number of matches in the previous case. That is 2 plus 1 equal to 3. Now, here, when the number of players is equal to 4, the number of matches is equal to 6. See, this 6, this is the sum of the previous number of players and the number of matches possible. 3 plus 3, 6. Similarly, when the number of players is equal to 5, the number of matches is this 4 plus 6, the previous case, the previous number of players and the previous number of possible matches, 4 plus 6, that is this 10 written here. Now, if we follow the same pattern rule, let's find out the number of matches possible in the remaining cases. So, when the number of players is equal to 6, can you say what is the number of matches possible? That would be equal to 5 plus 10, 15. Now, when the number of players is equal to 7, the number of matches possible will be the 6 plus 15, which is equal to 21. Now, when the number of players is equal to 8, the number of possible matches will be 7 plus 21, 28. Now, when the number of players is equal to 9, the matches possible will be equal to this 8 plus 28, 36. Similarly, when the number of players is equal to 10, the possible number of matches will be equal to 9 plus 36, which is equal to 45. So, here in this example, we first solved a simpler situation. Then, we tabulated those observations into a table. We observed the table, we looked for a pattern, we got the pattern rule, followed the pattern rule and solved the problem given to us. We found out that the total number of matches possible when there are 10 players is equal to 45 matches. So, this was one strategy where we can solve a problem. Let's see one more example today. So, here the next question says, a farmer wants to fence a part of his vegetable garden in the form of a rectangle such that the perimeter is 200 feet and the area enclosed is maximum. He also wants to place staffs at every foot along the fence. Find the dimensions of the fenced part. First step, read the question carefully and clearly understand what is being given to you. Now, here it says there is this vegetable garden. This vegetable garden is in rectangular shape. So, there is this rectangular vegetable garden and the farmer, he wants to fence this garden. He is going to build a fence around this rectangular garden. So, to build a fence around this garden, we need to know the total length of its boundary, which is the perimeter. The perimeter is given in the question. It is given us 200 feet. The perimeter of this rectangular vegetable garden is equal to 200 feet. Now, are the dimensions of this garden given? No. We need to come up with the dimensions of this rectangular garden so that we can build the fence around it in such a way that the area enclosed is the maximum. Now, it is also said that he also wants to place staffs at every foot along the fence. If he needs to place staffs at every foot along the length of this garden, the length of the garden must be a whole number. Imagine it's a decimal number. Will it be possible for him to place staffs at every feet or 1 feet apart? No, there will be some length remaining if it's a decimal or fractional number. So, the dimensions of this rectangular garden should be in terms of whole numbers. Now, we have to find the dimensions of the fenced part. Here this means that we have to find out the length and breadth of this rectangular garden. We are given only the perimeter of the garden, which is 200 feet. Now, tell me what is the formula to find out the perimeter of a rectangle? It is equal to 2 times the length plus breadth of the rectangle. So, here the perimeter is given as 200 feet. That means 2 times the length plus breadth is equal to 200 feet. So, from this, how can we find out what is the length and breadth of the rectangle? See, 2 times the length plus breadth is equal to 200 feet means the sum of the length and breadth is equal to 100 feet, the half of 200 feet. So, here we need to find out the possible combinations of length and breadth so that the sum of the length and breadth is equal to 100 feet. So, here one more thing has to be kept in mind. When we come up with a value for the length and breadth, we have to make sure the area enclosed with such a rectangle is maximum. So, the length plus breadth should be equal to 100 feet so that the perimeter will be equal to 200 feet. Also, the area, what is the formula for area? Length into breadth. When you multiply the length and breadth, it should give the maximum possible area. So, keeping these things in mind, how can we solve this problem? Here also, let's first solve a simpler situation. So, to simplify the situation, let's imagine the perimeter is equal to 20 feet instead of 200 feet. So imagining the perimeter is equal to 20 feet, let's draw a table that tells us the possible combinations of length and breadth to give the perimeter 20 feet and the area maximum. So to get the perimeter 20, the sum of the length and breadth should be equal to 10 because perimeter is 2 times the length plus breadth. So to get the length plus breadth equal to 10, the possible combinations of length and breadth are length equal to 9 and breadth equal to 1. The sum of length and breadth will be 9 plus 1, 10. Hence, the perimeter will be 20. Which are the other possible combinations of length and breadth to give you the sum of 10 feet? Length can be 8, breadth can be 2. So that the sum of length and breadth can be 10 to give the perimeter 20. Now, when length is 7, breadth is 3, then also you will get the perimeter 20. When length is 6, breadth is 4, the perimeter will be 20 itself, and when length and breadth are equal to 5 feet, you will get the perimeter 20 feet. Now, in all these cases, with all these possible combinations, you will get the same perimeter 20 feet. But look at the area in each case. When the length is 9 and the breadth is 1, the area, length into breadth, it is equal to 9 square feet only. But when the length is 8 feet and breadth is 2 feet, the area increases. The area becomes equal to 16 square feet. Similarly, length 7 feet, breadth 3 feet. Area is equal to 21 square feet. Length 6, breadth 4, area 24 square unit or square feet. And when the length and breadth are equal to 5 feet, you get the maximum area, which is equal to 25 square feet. So, when the perimeter is equal to 20 feet, to enclose the maximum area, the length and breadth should be equal to 5 feet each. So, this was a simpler situation solved by us to get a better idea of the problem given to us. Now, let's put this strategy here in this question to find out its solution. So, in this similar case, we imagine the perimeter to be 20 feet. Now, let's get real. Let's come back to the original problem given to us. Here, the perimeter is equal to 200 feet. So, here to get the perimeter as 200 feet, which are the possible combinations of length and breadth? The first case, when length is equal to 99 feet and breadth is equal to 1 feet, you will get the sum length plus breadth is equal to 100 feet. The perimeter will be the double of it, hence perimeter will be 200 feet. Similarly, when length is 98 feet and breadth is 2 feet, the sum will be equal to 100 feet, hence the perimeter will be 200 feet. And similarly, try to find out all the possible combinations which will give you the perimeter as 200 feet. And this might take some time, but you will find that the area keeps changing when the length and breadth change. Now, have a closer look at the table. You will see that when the length is 99 feet and breadth is 1 feet, the perimeter is 200 feet, but the area is 9 square feet or 9 square units. Now, you will see that when the length of the rectangle is equal to 50 feet and the breadth is also 50 feet, it will enclose the maximum area of 2500 square feet. Now, these are the dimensions of the farmer's vegetable garden, so that the maximum area is enclosed by the fence. So, here we got the dimensions of the vegetable garden as length is equal to 50 feet and breadth is also 50 feet, so that the maximum area is enclosed by the fence. So, I hope the questions we discussed today are clear to you. Now, you will be ready to work out a couple more questions from the exercise given in page number 252. You will be able to work out question number 4 and 5. So, you please do that and submit your answers in Microsoft Teams. So, that's all for today, children. Let's meet in the next class with the rest of the questions from the exercise. Till then, bye.